This is my 15-112 term project, titled 24141. And from the title, it's actually a reference to a mathematics course taught at CMU, Matrices and Linear Transformations. And it seeks to be an educational tool that features some of the concepts covered in class. So now I'll delve into the first function, which is a general matrix calculator, and it features matrix addition and matrix multiplication. Now, inside matrix addition, we can dynamically resize the matrix based on the number of rows and columns, and we can even navigate across entries within the matrix using arrow keys. And the entries within the matrix also dynamically resize based on the length of the entry of the entry input. So let's take a look at matrix multiplication. One key thing about matrix multiplication is to make sure the columns of the first matrix need to match up with the rows of the second matrix. And this app will prompt you if there is a mismatch. So let's try and perform matrix multiplication on a 3x4 matrix with a 4x3 matrix. Clicking solve, we're presented with the result here. And we can even see the steps that showcase how each entry is arrived at. There's also a transpose function. And now onto the Gaussian elimination function. So first, let's perform Gaussian elimination on a matrix. Now, clicking solve, we're presented with the matrix in reduced echelon form. And we can see the steps, and it tells you to exchange row 1 and 2, and then row 1 and 3. And it tells you the appropriate multiple, or rather pivot ratio to multiply by. Now, let's take a look at solving systems of linear equations. This app is able to actually tell you if your system has a unique solution, special solutions, or no solutions. So let's try a matrix that has a unique solution. And also, I'm entering the matrix as an augmented matrix. So the column that is golden reflects the constant within the system of equations. We presented the unique solution over here, and we can even see the steps to arrive at it, and they will show the steps for back substitution and how you arrive at the unique solutions. Now let's take a look at a matrix that has special solutions. And here are the special solutions at the end. Now finally, a system that has no solutions. And they'll present you the matrix in REF form first. And if you see show steps, you will find out, you'll see the explanation, which in this case, it's because there is an inconsistent system as a result of these last two rows, which is a row of zeros with a non-zero constant. Now let's look at a determinant function, which does so via cofactor expansion, which is actually a recursive method of obtaining the determinant. Let's try matrix, 3x3 matrix. Oh, and we can see the steps, and it will showcase the general step, which is at 0 depth, recursive depth. Now, the final function is the ability to plot directed graphs from an adjacency matrix. And one thing is an adjacency matrix can only contain entries 1 or 0. So the app only allows you to enter entries from 1 or 0. And maybe let's try generating a directed graph from a 5x5 adjacency matrix, which will produce a graph with 5 nodes. And this is the directed graph generated, and you can tell the direction of the arrow from the direction of the arrows, which node is referencing which, or which node is pointing to which, and that is based on the adjacency matrix that you enter.